We have seen many different ways that we can deploy access control lists within our organization. Another way is for securing access to our routers. So through the use of access control lists, you can define who is allowed to telnet to your router or who is allowed to use SSH to connect to your router. Now, if you're still using telnet, I'm going to recommend that you eventually stop using it and you switch over to SSH sooner rather than later. Why? Well, when you use telnet, everything that is transmitted between your router and your managed device, your management station, using telnet is passing plain text. So if some user is sniffing the wire, capturing that traffic, and you've typed in show run, they can see your entire running config once they've captured it. And if you are not using hashing or encryption on your passwords, they now have the information they need to launch a larger attack with elevated privileges later on. So what does SSH give you? SSH gives you the ability to encrypt all of the traffic that's flowing back and forth between your management station and your router, in addition to supporting a higher level of authentication. Whereas with Telnet, all you really need is a password. You don't even need a username with Telnet. With SSH, you are required to specify a username and a password on top of that. So if we look at this example here, they are setting up the host name for the router, which is something that you should be doing right away as soon as you get your router and you start configuring it based on your policies that you have set up. You have to have a domain name to generate cryptographic keys that are going to be used for the SSH session. So here they're providing a domain name of cisco.com. Then they're using the crypto key generate RSA command to generate cryptographic keys locally on the device. Remember what I said? We need a username and password for authentication. In this case, they're using local username and password authentication instead of a AAA server. But you can see with the username and password command, the username and secret command in this case, they have set up a particular username that can be utilized. But here's the thing I want you to realize too. No matter what, whether you're using AAA or not, you should have a local username and password on the device that you can use for backup purposes in case your AAA server goes down. So if all of a sudden a AAA server is not available, which means you would no longer be able to remote into your device for management purposes because, well, the AAA server can't authenticate you, this username and password could then be utilized as a backup to that procedure. So you could use admin with the secret password of admin 92, whatever other characters are there. And as a result, you'd be able to get in and manage the device. So keep that in mind. Not only are we using this for the local management in this case, but if we were using AAA servers, it would come in handy as a backup in case the AAA servers aren't available. Down below, line VTY configuration mode. They are turning on SSH and disabling Telnet with this particular command. Login local means ask for a password, but also use the local username and password database when you're checking the username and password that's being supplied. And they've set up an access control list to control who is allowed to use SSH to connect to the device. So let's set up SSH on R3 and disable Telnet. First things first, we'll go into global configuration mode. And what are we going to do? We are going to create our domain name, which is IP domain -name, and we're going to use route.local. So I'm just choosing anything in this case, but you would have in your policies the domain name that would be utilized for these particular scenarios. And we're going to create our cryptographic keys, crypto key, generate RSA, and let's give it a modulus of 1024. So we'll let it generate its cryptographic keys. It's done. SSH 2.0 has been disabled in this particular case, and it was re-enabled. So I had SSH version 2 turned on before, it disabled it, and then re-enabled it. So we're running SSH version 2. But if you weren't running SSH version 2, you should be running SSH version 2 or higher. You type in IP SSH version, and then you can specify the version number right there. So IP SSH version 2. We already have a username set up from before. Do show run pipe to include username. So we already have our username and password we're going to utilize, and it's our admin password, our admin username with the password of Cisco. That's not very strong. We should have a much stronger password, but I do it so that way there I don't lock myself out of this demonstration that I'm showing you right now. But in the real world, don't follow my password conventions that I'm using in my lab environment. And then we'll go to our VTY lines, line VTY 0 through 4, and now we'll specify that we are going to authenticate with the local username and password database. So in this case, we are going to currently be using what protocol? Well, Telnet. If I want to enable SSH, we have to say transport input and then specify the protocols that are allowed. You can specify all, LAT, MOP, none, SSH, Telnet. Those are the different options that you have. By default, Telnet is allowed, and on a lot of devices, SSH is disabled by default at the VTY lines. But I've seen a transition to newer devices with newer operating systems having both Telnet and SSH on by default. But if you just want SSH, as we said, SSH and nothing else, no other protocols, and you just type in transport input SSH. If you want to allow SSH and Telnet, then you specify both. And the order doesn't matter here. You can say Telnet SSH, SSH Telnet. It means the same thing, that you are simply allowing both those protocols. So I just want to allow SSH in this case. If we look at the output of show run, pipe to begin line, we go down to line VTY configuration mode, we'll see that we still have our line password set up, but it's not going to be used. It's not going to be used because we typed in login local, which means ask for a password, but verify the username and password against the local username and password database. And we've turned on SSH on the VTY lines. Let's go over to R1, and we'll type in SSH, and then we have to specify the username, -L. The username is admin, and then after that, we got to specify the IP address. So 10.1.13.3, that's the IP address of R3, and SSH connectivity should be successful here. It's asking for a password based on the username and min that we provided, and success, we have connected. If we go over to R2 and do the exact same thing, I'm going to copy that, go over to R2, paste, and in this case it's 10.1.23.3, that's the IP address of the interface on R3, but we should be able to connect to 13.3 because we have our routing protocol set up. Should be able to, and we can, so we'll use the same IP address for simplicity's sakes. And now I got to use the correct password, and we have successfully connected. So right now, everybody's allowed to connect. Everybody. As we saw, we could use access control list to define who's allowed to use SSH to remotely connect to our devices. So let's set up an access control list now to do that. Access list 10, and we are only going to permit anybody that's connecting from the IP address 10.1.1. or 10.1.13.1.0.0.0.0 just for this demonstration. And then we are going to say access list 10 deny any log. So I've taken the implicit deny all and I've made it an explicit deny all with the log keyword because I want to log all those attempts to use SSH to connect to this device from users that aren't supposed to be trying to connect to this particular device. So it's going to give me the opportunity to see messages in relation to that. So for me, it's not just about, oh, yeah, okay, fine. I've denied people from being able to connect. I want to know. I want to know who's trying and keeps failing because they're not allowed. So let's go back to line configuration mode now. Line VTY04. And we are going to say access class 10 inbound. So applying this access list to the VTY lines inbound. So now only show access list 10. Only this user should be allowed to use SSH to connect to R3. So let's go back to R1. We'll issue the same command, and it's asking us for a password. And I typed in my password incorrectly again. Let's try it again. There we go. Can't seem to type Cisco for some reason today. And we successfully connected through from R1. But if we go to R2 and we execute the same command, connection refused. And the connection is refused because of the access control list. And if we look at the access control list now, we have our successful match that from R1's connection, but then in this case, R2 was denied, as we can see, and we were able to log that message. And we even have a syslog message appearing that says, hey, you know what? Somebody at 10.123.2 tried to connect and they were denied. So not only do we get this here, but since we specified log, we're also getting a syslog message on top of that.